Hello everyone and welcome back. In the next video series, we'll refocus on more advanced features of React related to optimization, performance, and scalability. In this video, I'm going to use question and answers to review strategies we've already implemented in our application, such as Redux Toolkit, useEffect, useSelector, React Router DOM, and Redux Persist. In future videos, I'll share other strategies that we haven't talked about, such as use memo, caching, and code splitting using lazy loading and suspense. This is part 1 of the question and answer series, Optimization, Performance, and Scalability. Subscribe to be notified when part 2 releases. Let's get started. How does Redux Toolkit work, and why is it a great tool for optimizing global state management? That question was answered in part 4. We left off with this diagram, visualizing how Redux works overall. We're going to take a deeper look at the store and understand the slice, state, the reducer, and actions to see how these work together to manage the global state. And what makes Redux a great tool? It's simple. The Redux store, reducer, and actions are centralized in one location, so it's easy to manage and update data. It's opinionated, which means that you're working within structured, built-in defaults, so it delivers a consistent code base. And because of its powerful Immer library, you can quote-unquote modify state, something you normally can't do directly in JavaScript, and you can see updates immediately to your application. And it's effective because with Redux, you can do more with less code. Under the hood, createSlice automatically generates reducers and action creator methods, simplifying state management. It also uses Immer, allowing mutating logic and reducers while keeping updates immutable. For the full tutorial, check out the card in the link above. How does Redux Toolkit optimize state management when handling API requests and responses? This question was answered in part 10. This tutorial has to do with using an external API or database. When we introduce an external API, we are introducing delays in receiving and sending data. So we need another tool that can handle the delays that are introduced with external APIs. And Redux provides a more powerful tool called createAsyncThunk. And it is a middleware that allows us to create super action creator methods called thunks. Now, thunks have the ability to multitask. They allow us to send and receive data from the database and at the same time perform validation and modification on the data we receive and send. Thunks perform error handling as well as data processing. Thunks handle all these interactions while ensuring that the application remains responsive while waiting for the server to respond. The Redux slice will automatically generate lifecycle actions to handle pending, fulfilled, and rejected state. So now let's take another look at the post slice and create our first thunk. So the first thing we need to do is import the createAsyncThunk into our post slice. And we simply need to add it here, createAsyncThunk. So right above the create slice middleware, we'll initiate the createAsyncThunk that we just imported from the Redux Toolkit. We'll initiate it here and assign it to a variable that we'll name createPostThunk. And we also need to include the keyword export because we want the thunk to be accessible wherever we import it in the application. And we're going to feed the thunk 2 parameters, the action type, which is post, create post thunk, and we're going to feed it a function, which is the async function. And let's correct this. This should be lowercase. This first parameter lets Redux know to associate this action type with the thunk. And it should be thunk here at the end. And the second parameter, the async function, is where all the asynchronous logic resides. So let's move this down. We're going to pass to this function an argument post-arg. That's what we're going to name it. This was sent over from the component and will be sent to the server. For the full tutorial, check out the card in the link above. How can you leverage Immer's mutation-friendly methods to avoid full array replacements? On its own, Redux Toolkit provides solid performance. For example, it only updates part of the state that changed, thanks to Immer's efficient handling of immutability. Additionally, its built-in middleware and thunks are optimized for performance right out of the box. But as our application scales, our goal is to reduce iteration and avoid full array replacements when updating state. Using map and filter in reducers can become inefficient in large applications, especially when working with thousands of posts. So here in our update post link, we can use find index to find the post without iterating through all the entries in state. So instead of mapping through the post, we want to find the index that meets this condition. And we're going to get rid of this. We're going to save it in a variable, and we're going to call this post ID. And now we're going to go down, and if the post ID does not equal -1, because -1 means that it doesn't exist. So if it's not -1, that means that the post exists. And if it exists, then we want to update state entries post ID equals action payload. So while this approach may be less intuitive, it aligns better with Immer's strength in handling mutations rather than handling iterations. This is the part that Immer is concerned about. It simply wants to update the post that had the correction. So let's save this. And we are going to test it out on the front end. So let's start off with a new post. I'm going to call this 2024, new post description 2024, and new post author. I'm going to make that 2020 and create that as an era. Okay, so now I'm going to go back in and I'm going to use the new code that we just created, that we just updated for Immer. And we're going to see if our updated code is working. And I'm going to change this to 2024, and it should work just fine. Great. So we see that that post is working. I'm going to delete that so that we have less on the page. And now let's go back to the front end. We're going to do the same thing here in deleting post thunk. We're going to go down. We're going to create a variable for the post ID. And we are going to find the index of the post we want to delete. So that's going to be entry equals. So we're going to find a post that meets this condition because we want to delete it. And then we're going to go down. We're going to pretty much do the same thing that we did above. If the post ID does not equal -1, if it doesn't equal because if it equals -1, that means that the post doesn't exist because arrays start at 0 and above. So if it's -1, that means that it doesn't exist. So we're saying if it exists because it's not -1. Okay, if it exists, then we want to delete it. So how do we delete it from state? We're going to state entries, and we're going to use splice. And we are going to remove the post ID. We're going to remove this entry that we found, and it's only going to be one item. Immer loves this code because we're not recreating the array. Splice mutates the draft state, quote unquote, it's mutating state. So it tracks these changes and applies the changes to state. This is much cleaner and faster, especially when we're dealing with large data sets. It's not going through and iterating or filtering, and it's not going through and replacing the array. It's simply removing the item that needs to be removed. So I'm going to save this, and we're going to see if this works. Let's go back over to the front end. And now I'm going to create a new post. I'm just going to call it 2024, 2024, 2024. We're going to create it. And now I'm going to see if I can delete it. And it's gone. Okay, so that code works as well. For the full tutorial, check out the card in the link above. How does Redux Toolkit efficiently handle in-place state updates during CRUD operations? This question was answered in part 11. The extra reducers handle actions created by createAsyncThunk. These actions are the lifecycle stages: pending, fulfilled, and rejected. So how do the life cycles, and especially their responses, help us on the front end of our post application? Well, just as we are able to display post data on the front end, we can also communicate with our users by displaying a message in the UI from the server. So for example, if we try and create a post and the response was rejected, we can communicate a custom error based on the response. So taking a look at this code, the pending, fulfilled, and rejected lifecycle stages manage the status of API calls, and the status property helps control whether certain parts should update. So for example, when the create post thunk is pending, the status is updated to loading. This helps prevent redundant API calls if the post data is already available and the status hasn't changed. But to further minimize unnecessary re-renders, we want to make sure that we only update status when a change is truly needed. What do I mean by that? Let's just say an identical new post is pushed into entries at the same time by two different users. Immer will see each new entry as a new array reference and re-render the component. To prevent that, you can check if the post already exists before adding it using the sum method, which returns true if the post already exists or false if it doesn't. So directly below the status, we're going to create a new variable, and we're going to call it post exists. And we're going to take a look at the entries in state using the sum method. And we are going to see if an entry meets this condition. If the ID of an entry matches the action payload ID. So we're going to find that post. So if post exists is false, that means it's not in state, then we're going to push the new entry into state. And this is mutating logic, so we're going to quote unquote mutate this copy of state by pushing the new entry in. And this ensures that you're only mutating state when the post is actually new, which helps avoid redundant updates and keeps the UI performant. For the full tutorial, check out the card in the link above. How can we provide performant UX, UI, and avoid redundancy when making asynchronous API calls? As a backup, we're also using this post status property to conditionally render UI updates based on the current state. After dispatching our actions for the update and create post thunk, we make an async call to the API using the unwrap method to handle the promise. Now, this unwrap method allows us to access the lifecycle stages. And for example, here on the button, if the lifecycle stage is loading, this changes the disabled property on the button to true. So users can't submit another entry if the button is disabled. Using unwrap ensures that you're only mutating state when the post is actually new, which helps avoid redundant updates and keeps your UI performant. For the full tutorial, check out the card in the link above. How does useEffect improve performance by controlling when data is fetched and preventing unnecessary re-renders? This question is answered in part 13. And here's the setup for the useEffect. useEffect has two parameters. The first parameter is a callback function that contains the code that will run after the application loads. And in our case, that is going to be to dispatch the fetch post thunk. So let's type that in. We wanted to dispatch the fetch post thunk. When fetch post thunk is called, it dispatches the fetch post thunk action, which is an object that includes type pending, fulfilled, and rejected. And it automatically returns a fetch post thunk action, which is an object that includes the type. The types are pending, fulfilled, and rejected. And if these types sound familiar, it's because these are life cycle stages. Now, continuing with useEffect, there's a second parameter, which is an array, an optional dependency array, which controls when certain logic should rerun, ensuring that we're fetching or refetching data only when it's necessary. If it's empty, the effect runs only once after the initial render or when the application initially reloads. For the full tutorial, check out the card in the link above. What role does useSelector play in improving the performance of React applications to ensure that components only re-render when absolutely necessary? Imagine we're building a new project that has existing posts stored in an external API or database, but moving forward, we need to create new posts. So first, calling fetch post thunk inside useEffect ensures that we receive the complete data set from the database, including existing posts when the application loads initially. So fetch post gets older posts from the database and updates the Redux store with those posts. And second, once the Redux store is populated with those existing posts, useSelector provides access to the existing post on the front end, but it also ensures that the front end stays up to date with any new changes, whether you're creating, updating, or deleting posts. And here's the important key to remember. Once the initial fetch is completed, the app doesn't need to reload the entire data set again. Instead, useSelector gives us access to the current state of the Redux store, and the UI updates dynamically when new posts are created, updated, or deleted. So only part of the UI needs to re-render, keeping the application efficient. This data flow prevents unnecessary refetching or reloading of the application by separating initial data loading from fetch post thunk from UI updates using useSelector. And here's another question about efficiency and performance. Should we add here posts so that the application updates whenever there are any updates to the post? Well, unless it's absolutely necessary to perform a specific action, such as a recalculation, in general, we should avoid using the dependency in useEffect since it causes unnecessary refetching or reloading. Remember, useSelector gives us access to the current state of the Redux store, so we can remove this post. For the full tutorial, check out the card in the link above. How does React Router DOM improve user experience and performance during navigation? Routes include the functionality to navigate or switch from one component to another when the path in the route matches the current URL. Routes preserve state and prevent page refreshes, which provide a better user experience and improve the app's performance. And we'll import link from React Router DOM, and we're going to include link to post lists. We're using link from React Router DOM, so we don't need to include the component. And since link is part of React Router DOM, the page doesn't refresh when the link is clicked. Let's save these changes and then move to the nav component to create links there. Let's import nav link from React Router DOM as well as link. Both navlink and link prevent the page from refreshing when the link is clicked. And inside the nav element, we'll include nav links pointing to paths for the nav menu items. Starting with the post path, let's copy and paste and include a path to the about, as well as a path to the contact menu item. And if everything looks good, we can save. For the full tutorial, check out the card in the link above. What strategies help maintain Redux state across page reloads to improve performance and reduce redundant API calls? This question was answered in part 16. Redux Toolkit stores data in memory, which means data is lost when the page refreshes, the app reloads, or the browser session ends. Since the Redux store doesn't persist across sessions, which means the period of time a user interacts with your app in a single visit, the post would need to be refreshed from the API each time the application starts. To maintain data across page reloads and avoid unnecessary API calls, we can use local storage, session storage, or a more advanced solution like Redux Persist, which can persist Redux state in storage mediums like local storage or session storage. One key difference is using local storage alone requires manual handling to store and retrieve data, while Redux Persist with local storage or some other storage medium automates this process by automatically saving and rehydrating Redux state to and from local storage. Redux Persist integrates with Redux Toolkit and offers more control and automation. Even in this small application, using Redux Persist with local storage to store posts can reduce unnecessary API calls. Where Redux Persist really shines is for storing authentication tokens. For example, if we had a login system, Redux Persist would keep users logged in even after navigating to other pages or reloading the app. So with that, here's where we'll end our video today. This wraps up part 1 in our question and answer series on optimization, performance, and scalability. If you found value in this tutorial so far, don't forget to like and share this video. Also, subscribe to the channel and hit the notifications bell button. If you want to be the first to know, connect to the Hub, Source Coder Hub's community. Thank you for joining me, and I'll see you in the next video.